How's it going, everybody? I Before I start my little spiel here on what we're going to cover, I wanted to go over a couple things that I thought were pertinent to the situation. I get a phone call from my mother-in-law, and I'm in the middle of actually recording the series, and she goes, "Is there any way that you'd be able to help a friend of mine? She's a teacher at the same college that I attend here in Wisconsin, Gateway, and but she teaches at the Kenosha campus, and she does like flower design and stuff like that. So she's been a florist for as long as I've never known her, and I'm like, well, what's the problem? And she goes, she's totally not technical. I mean, she has a hard time printing things and barely can find where she saved something. So I'm like, well, I can try. And so she calls this other person. Now she doesn't know how to do a three-way call, so she can't just bridge the calls together and make it a three-way. So she gives that person my phone number. That person calls me and says, the spiel basically came down to they had some work done recently on their network, and she goes, I left them for a couple hours to go take care of some business, and they said that they had everything under control. I'm like, she's like, okay, no problem. I'll be back in a little bit. She goes 2.5 hours later. I come back. Their cars are gone. All of their tools are gone. She walks in. There are cables everywhere. She has cables she didn't even have to begin with when she left. Equipment that she didn't have when she left. So she started off with a rack very similar to my rack, which is, hang on one second, I'll pull up a picture of it. Very similar to a picture like this, where you've got a few routers, a few switches, and some connectivity. And she had cables out of the wazoo. Things are plugged in that weren't plugged in on one end, but not on the other. The wrong type of cable plugged in there, and she basically was like, "I don't know what they did." So I'm like, "Okay, well, where are you?" So she gave me her address, and now I live, if you know where Milwaukee, Wisconsin is, I live just south of Milwaukee, by about a half hour. And, well, we'll just say I live in Milwaukee because it's the closest way. I live smack dab in between Milwaukee and Chicago, but closer to Milwaukee. So I make the hour drive west to a city called Waterford, and I drive out there. I get to this place, and I walk, I knock on the door because it's locked. They're after hours. I get there, and she's like, "Oh God, thank you, you're here." And I'm like, I walk in, and there is just a mess of cables. There's routers. She had 1700s, 1900s, 900 series routers. She had switches they had brought in a 4500 series chassis switch. They put this thing. This thing was just sitting on the floor in the middle of her office, and I'm like, "How big is your How big is your office? How big is your network?" She has 25 people that work for her, and there's an additional like 25 that work in production that you know take care of producing orders, and there's 5 computers out in the production that are dropped back into a switch that's in the office. She's only got one switch. It's a 48 port switch, so more than enough for everything that she needs. And then a couple ports going off to her routers, a couple ports going off to the servers, and that's it. It's what's a one switch, one router network. And she's like, "What do I do?" And I'm like, well, let's figure out what we can do, And I'm going through, and the first thing I did is, since it took me a little while to see what they did, hardly any of that stuff needed to be fixed, put in. So for me, it was just like, well, if it doesn't belong, take it out. So I took everything out. I had a stockpile. I had the 4500 on the bottom. I had all these switches. They brought in 5 3550s. They brought in some other stuff, and But you're thinking, well, why didn't you appropriate this stuff? Well, because of the fact that no power cables, and every time I would try to boot something with my power cables here, nothing would load. It's like it was all bad equipment. Like they just had bad equipment, they needed a place to stick it. So I'm thinking they may have stolen it, but I wasn't about to sit there and mess with that. So she calls the local police department. They come out, they take a look at it, they do an inventory, and she gives the description of these guys: 2 white guys in a white van. So, long story short, it took me a few hours. I got her back up and running, and she has a 1941 that has a single fast Ethernet cable going to her 2960 switch, and she's got a couple VLANs that I have her set up on. And as a matter of fact, I am putting in a 3560 8-port switch in there next week, and that will be doing her PoE because she wants to convert from her regular digital phone, like you'd have a little RJ11 cable. She's flipping over to PoE. She wants to go voice over IP. So I was like, okay, no problem. So she's gonna buy the equipment and slowly migrate over to a voice network and go that route. So good stuff for me. Now, one of the things that I wanted to cover, I'll go ahead and close this out. This is our current topology right now, because that's what we're going to work with, because the other one blew up on me. So what we're going to do is, this is the original connectivity for what we had. Now, well, actually, I take that back. That's that's the old one. That's the one where I changed it out. But what we're going to do is, since we don't have a server farm, what we are going to do is, I'll have to pull up the PDF of it, is, actually let me fire this up real quick, let you guys see how that works. Now, I know yesterday I discussed a little bit about how the new change with the new CCNA exam is and stuff like that, and I don't want to freak anybody out, but all in all, it's really not that bad. And you're thinking, well, yeah, because you know what you're doing. Well, that may be true, but at the same point in time, it's really not that bad. I mean, if you understand the CCNA, the ICND1 exam, which is the CCNT exam, if they've taken a lot of stuff out of it, like they have the security track, they have the wireless track, they don't need to really bring that up, because that's actually, when I took the CCNT exam and passed that, that was a lot of wireless. I think there was all the wireless, all the security, I got all that stuff right. So, but it's been 7 months since I've taken the exam, so yeah, I might be a little rusty on some things, but the idea is my test is on 4/2 of 13, which is, right now it is 3/29, so it's technically Friday morning, so I'm going to take the test on Tuesday morning. So when I get up in the morning, go take the exam, come home, eat something, head off to work, and hopefully it's a pass. Can I say that I am 100% ready? I feel like I'm confident that I'll pass, but I never say that I don't know a reason why I wouldn't pass, because I said that before and I failed. So this will be my 3rd attempt. No, I don't feel ashamed at saying that, because realistically, you may think you know it. You know, that's the real thing. You can study the stuff till you're blue in the face. You know, you can recite everything there is to know about spanning tree, routing, switching, you know, go into the CCNP level stuff, learn all that stuff. But in reality, if you may not know it, and that's the true statement on it. So what I'm going to do is, I'm going to do my best when I go take it, obviously, and right now, it's just, for me, it's going to be a lot of making sure I can nail down what I need to nail down. And right now, what I'm going to need to nail down is, I need to go back through IPv6, and I'm going to discuss NAT and ACLs here with you guys right now, because I'm actually going to pause the video for a second and check to see if my processor is, wigging out right now. Okay, I finally got a idle PC value, and the way you do that is you right click on this guy, go down to idle PC value, and that settles down whatever particular process was taking all the utilization on the router. Cancel. So what we're going to do, this is our topology that we're going to work with. But however, I have this fancy little gadget called Paint, and Paint allows me to, draw. So nice feature. It allows me to draw, and as I'm talking to you guys, point things out and explain as I'm going along. I figured it'd be easier to, instead of doing this and then doing this, it'd be easier to draw it out and stuff like that. So that'll come in handy. So what I'm going to do is grab the, not that, goodbye, drag this, there we go, and drag this over. I know yesterday I discussed OSPF Areas area types a little bit with you, so I'm going to kind of pick up from where I left off and go from there. Now I know it says right here. I know what was it? What was I going to say? I know I discussed how OSPF areas work, and I went in there and I showed you how the neighbor command and with the priority 0 and stuff like that, being able to make sure that they don't come up as DR BDR election. So what we're going to do now is, since the routers are all turned on, I'm going to console into it, and that'll allow me to show proc CPU sorted. That'll let you see what's going on the processor. So right now PPP is running because we know that PPP manager IP ARP is going through. Now the one thing you don't see is IP input. You don't see that in here. So like if I was process switching, or if I was using the processor on the router to switch my packets, then you would see that. But I'm doing Ceph switching. Show IP Ceph. Ceph switching is hardware switching. What that means basically is this. Whenever didn't want to do that. Come on. There we go. Whenever you have Ceph switching, Cisco Express Forwarding, which means it's hardware switching. Ceph is a layer 2 feature, and what that does is it allows you to use the backplane of the switch, or the router, or the backplane of the device to do the switching rather than the processor. It's hardware switching. So basically what you're going to do is Ceph learn is a copy of the routing table. So your routing table should look like this. It won't look quite as, the routing table will look a lot cleaner because it's specific routes, where this guy has everything. So what it basically does is when a route needs to get moved from one place to another, so one interface to the other, what it basically does is it comes in here and the Ceph table builds an adjacency table. And what that means is it already knows the layer 2 address of the next hop router. It already knows what the outgoing interface is, so it's that much faster at having to route. So what it does basically is something comes in. Oh, not what I wanted to do. Where is my pane? There's my pane. Basically this is what happens. So if you send something from here, from this guy, up to here, what it does, as soon as it hits this router on this interface right here, it comes in. This router says, okay, well, anything going to the 198.198.1.0 network comes in. I don't have the 198 network configured, but let's say we do. It comes in here, and it's going to see this, and it's going to go, okay, so that's where your destination is. How do I get there? Well, because I have Ceph running, what that does is it allows me, let's crunch this down just a little bit. There we go. What that does is it allows me, or allows the router, I should say. Let's bring this guy up. There we go. Now we're cooking with fire. So what that does basically is when something comes in on here and it's got a destination of say 192.168.1.0, which is this way over here, what that does is it says, okay, well, what we need to do is we need to figure out how to get there. So it looks at the routing table and says, well, I need to find out how to get to 192.168.1.101. and the router says, oh, okay, well, let me look at my routing table and see how that works. So he looks at the routing table and he says, okay, no problem. How do I get there? Well, I'm going to ship it out the fast Ethernet 0/0 because how do I know that? Because it shows it right here. If it comes in on the 192.168.0.101, it comes in on that interface. Well, okay, let's say for instance it comes in on another interface. Let's say for instance it comes in from the PPP link. Let's say it comes in from 172.20.0.170 or 0.170. It comes in on this interface right here. So he says, okay, this is the inbound interface. So he says, well, but my destination is 192.168.1.1. And he goes, okay, well, how do I get there? Well, he already knows the 192.168.1.1 is the next hop IP address to this device. So comes in on here. This guy says, okay, well, I know how to get there. That's this way. So he already knows the next hop IP address. He knows the outgoing interface. He already knows the MAC address of this guy right here. So all he's got to do is take that and ship it right back out the door. So as soon as he does what's known as a recursive lookup, and he says, okay, well, how do I get there? Well, actually, it's not a recursive lookup. A recursive lookup means it comes in on one and goes out at the other, but it's still got to look in the table to find out where to go. Ceph does that for him. That's what actually is happening. Is Ceph does a recursive lookup for the routing table. Instead of the routing table having to run to find either the shortest path first or the shortest hop next router or the next hop IP address, it looks up based on Ceph. So Ceph finds it, shoots it out the next interface. So anything that comes in on here for the 172.20.0.170 network, this interface right here, as soon as it comes in, he says, okay, well, but my destination is this. Because basically what ends up happening is this. It may help if I was to explain this a little bit more in depth. This guy right here says, I want to get to Yahoo. Okay, this is how he gets to Yahoo. So he needs to get from here to here. Well, how does he do that? Well, he says, I need to get to Yahoo's IP address. Well, he knows how to get to Yahoo's IP address via another IP. But what he does is, this guy says, I need to get to yahoo.com. So it hits this router. This router says, well, I don't know how to get to Yahoo, but I have this fancy thing in here called a default route. Right here, this is 0. It doesn't match anything that's already in my routing table. So he says, well, how do I get there? Well, this is how I get to that IP address. This is the prefix I'm trying to get to. This is how I get there. This is the interface I leave on. So what he does is he says, okay, well, my first hop is going to be this. It's attached, obviously. So what he does is he leaves out this interface on Plymouth, okay, hits this IP address because it's the receive of this guy. This guy says, okay, well, in order to get to this IP address, this is how I've got to get there. Okay, so he hits this IP address, goes out this interface to get to this prefix. If it doesn't match something that's in the routing table already, it's a dump route. The router just send it out to the internet. It says, okay, well, it's not something I can route internally, so obviously it's got to go outside of our network to get there. So that's how it goes. That's how your router makes a decision. Now, let's just say, for instance, that there were switches in between. Okay, let's say there was a switch. So let's say, actually, let's slide this guy out of the way here. We have a switch. Okay, so this router says, I want to get to the internet. Well, what ends up happening, let's say that there's a user behind here. Let's say, for instance, that there's we'll put a host machine right there, even though I don't know if that's going to work. Okay, we'll say this guy needs to get to the internet. Well, what he ends up doing is his IP address is the source IP. Okay. Oh, that's kind of cool. I know I can connect live computers in JNS3. I've never done it. But he says, I need to get to the internet. So his destination, his source IP address is his IP on his network card, his configured IP address, whether it be statically or DHCP assigned. So that's his source IP. His destination IP is yahoo.com. So DNS, which is configured on this router right here, says, okay, well, the IP address to Yahoo is something that is not in my routing table currently. So I don't have a Yahoo IP address in my routing table, so we're gonna use this guy to get you there. So if you don't have a default route out to the internet, it's just gonna time out on you because it doesn't know how to get there. So what ends up happening is this packet comes in here. Well, actually, the frame comes to the router. The router says, okay, well, my next hop is this guy. So what he ends up doing is he rips the MAC address of this interface off, switches it over to the MAC address of this guy, and ships it out this way. This switch already knows the MAC address of this interface and this interface right here. So what he ends up doing is the source and destination IP address never change. Only the MAC address changes, going from hop to hop. So right here, the switch is just transparent. It already knows the MAC addresses, so it knows to get from here to here, it's got to go through this direction. So it gets to this MAC address. So what ends up happening at that point is all the frames that need to be switched or sent out to the internet. If this guy is load balancing across the PPP multi-link that we have right here, then all he does is takes this information, rips this MAC address off, and applies this MAC address here. But what he ends up doing is, let's say for instance there's only one connection. So this guy right here puts the destination MAC address of this guy right here. Okay, the source is here. So once all the frames are sent across the wire and they get here, the MAC address becomes a source, this becomes the destination, and the process repeats itself until it actually gets to where it's got to go. Until you don't use MAC addresses anymore. You may use frame relay. At that point, you're using a DELC. Or it may be going across the MPLS cloud, and at that point, you're label switching it in the provider's network. So what you end up doing at that point is the MAC address gets, this is the source, this guy's the destination, this is my home router right here, is what it goes to. So at that point, he says, okay, well, this becomes my source, this is the destination, because this is how we're going to get there. We don't know how to get there, so we're going to send it out to this IP address on this interface, which sends it from here to here. This guy gets it, brings it to here, out the door it goes. Now, let's say for instance let's say for instance this connection is not here, and it doesn't know how to get there. What happens? Well, what'll end up happening is the packet will still go the same route. You know, the MAC addresses will get switched from this will be the destination, going from here to here. Then this will become the source. This will become the destination, so on and so forth, until you get to here. What this guy will do is he'll send that frame, that packet, with that information. You know, the source and destination IP address, source and destination MAC address, all that, the payload, the headers, everything that needs to be there will be encapsulated. This stuff will go across the wire, but it'll be sent out to telco as a private IP address. Okay. Now, in my case, that's not going to happen here because of the fact that my router's already NATing, so I don't actually have that luxury of doing it. So, what'll end up happening at that point is, well, it'll still get sent out. But let's just say, for instance, this right here was my home router, and this was the actual internet. This was an actual like telco cloud. It's not a virtual router going to my router out to the internet. Let's say this is my home router. Okay, what'll end up happening is this guy will come up here, well, actually, let's cut the link here. So there is no outside interface. There is no outside internet to this topology right here. So what ends up happening at that point is this guy gets it and says, okay, well, I'm going to ship it out, but that's it. So it gets to another router over here. Let's say this is another router that doesn't go anywhere. It's a dead end. So he gets the packets, and he looks at the headers and says, Oh, well, that's not anything I know how to get a hold of or how to route to, so it just drops the packets. So at that point, the packets just, they die. They're just no longer there, but this guy sends an ICMP unreachable back to this client. And that basically says destination, what is it? Um, destination unreachable, I believe it is. Because it wouldn't be port, because destination unreachable. You get like a u.u.u as you hit it. If there's nothing there, so let's do I don't know if I can do that. Oh, you know what? Let's just turn it off. Config T interface fast0/0 and we'll shut it. So now that turns off that. And we're going to go to R5. We're going to go to console. Alright, so here's R5. And here's R1. Alright, so my interface is down. But we still have a route in there to get there. Right? We still have the 0 route configured. So we're going to ping 192.168.1.1. Yeah, it's not gonna, I don't know if it's gonna do it or not. Let's see if I have DNS turned on here. Show run. I think I just put a router in here to, actually, what is it? Does it? Yeah, it does. It does have a, okay, so we're gonna ping www.yahoo.com. So it's gonna transmit, but I don't know if it's actually gonna go through. Yeah, unrecognized hoster. Yeah, because it's the port is shut off. So we can telnet. We can try telnetting to 192.168.1.1 destination unreachable. Sometimes you'll get destination unreachable. What that's doing is you're getting an ICMP unreachable message. It's I think probably protocol 1 is what it is. You'll get that when it can't get there. So what I'm going to do is I'm going to go back on R1. I'm going to do no shut. And that should bring it back up. And there you see it. So we're going to, okay, and then DHCP reassigned it because it knew the MAC address, and we're going to ping yahoo.com again. So it's going to pull that up, and I don't know if it's going to work. It should. Okay. Interesting. You know what? I can show IP route. Oh, wait. Oh, I gotcha. I see. I gotcha. Right here. Because it thinks 20.1 is it's let's see here. Let's end show IP interface brief. 20.1. What is 20.1? Oh, that's this router. Show IP interface brief. 20.1. That must be R4. Oh. Yeah, that's gotta be R4. R4 is console. Because you gotta figure out where it's at. Show IP interface brief. Yeah, that's this guy. This guy is 20.1. So actually what we need to do is show run. He may not have had it turned on. Yeah, he doesn't have IP domain lookup. So config T, type in IP domain dash lookup. That's my fault. And lookup. Type in IP name server. It's going to be 192.168.1.1. So what we're going to do is we're going to go back to R5 here and try this one more time. because now we're pointing it. Okay, show IP, show IP domain, unrecognized. Show run, include, or section, IP domain. Yeah, it's gonna squawk at me, be like, I don't know what you're talking about. Yeah. So, let's see if we can just ping it. Nah, let's see here. R4. Let's see here. You know what? I bet you any money. Show run. I bet you I have it configured as 192.168. And I do. Config T. Let's see here. IP name server is going to be 172.20.0.1. Let's see if that helps. And try that one more time. No, it's gonna bug out on me. Show run. IP domain lab.local. Oh, it's gonna. That's my fault. Anywho, I'm over here trying to be all funny and fancy, and it's blowing up on my face. And ping www.yahoo.com. Yeah, it's gonna fail on me. Show IP route. Does it know how to get to 192.168? It should. .170. And I've advertised on R1 that if you don't know how to get there, show IP route. Because all I did is I redistributed it. Oh, I see what it is. I gotcha. Show IP interface brief. Oh, I'm on R5. My bad. I'm on an R1. Show IP route. Yeah, he's got. Yeah, see, I've IP default. See, it's got default gateway of last resort is 20.1 because that's technically it's default gateway of last resort. R4, his is 172 or 172.20.1.0.170. So basically, they're just supposed to all forward. Can I ping 192.168? I can ping it. I can ping it. So, interesting. I may have to go into my router and configure a default route. That might be the problem, which is no big deal. Actually, hang on one second. I can actually try to do that. Okay, so basically what I've done is I'm on my home router. It's just it's an old Linksys DSL cable router. So basically what I did here is we go to here to advanced routing, and then if you put in here, if you do show routing table, you should have a destination LAN IP is 0.0, subnet mask, the default gateway is out to the internet. So anything, if he doesn't know about it, then it goes out the default gateway. This basically just goes up. So basically what I can do is I can put a default route in here, and actually it's weird that it's doing that. What I could do is I could put a route in here and say, okay, well, this is what we're going to do. If you get this, then This is what you're going to do. So NAT is enabled. Transmit RIP version. I could put RIP version 2 in here and route RIP. The RIP routing the RIP protocol regularly broadcasts routing information to other routers on the network. Yes, it does. So what we're going to do is we're going to say, if you are it's a 0 route, 0.0.0 on 0.0.0.0, the destination is, well, that's just kind of a waste of time because it's going to be the same no matter what you do. Because it's not like I'm trying to route something somewhere else. So, it's, I don't know. I thought it was going to be a little easier than that, but because before I was actually able to go to R1 and telnet to telnet to 4.4.4.4 on, I think I can do, what is that? To telnet 23. It may not support it, but it's trying to open a telnet session from R1 out to the internet. So, yeah, I don't think it's gonna go. So it'll hold up for a minute. If it can't get out there, then it'll just come back and say denied. While I'm sitting here waiting for that, a couple things that I'll go over with you. Yeah, it timed out. This PIM Auto RP, that's multicast, which is PIM is protocol independent multicast, and basically what that does is it routes your multicast traffic, and it's its own independent routing protocol. It still uses the routing protocol or routing table of your routers to learn the routes and stuff like that, but it's a sparse mode, meaning it only sends out multicast to clients that request multicast, and if you didn't request it, it won't send it. So Auto RP is an auto rendezvous point, which is like a router out on the internet or on your local network that all of the multicast traffic is sent to. It's like a you open up an application on your computer, like YouTube would be an auto RP, and you go out there, and when you request it, that's when it starts sending it to you. So we're actually going to trace to 8.8.8.8. I don't know if it's going to work. I'm curious from a router here. Yeah, it's not gonna. It doesn't do it. Can I ping 8.8.8.8? Sweet, I can ping it, but I can't trace to it. Go figure. Because in my setup I have Google DNS as my DNS server. So, alright, well, no big deal. Close window. So, that's it for this video. I wanted this more conceptual stuff. Feel like I kind of left you hanging there. But I'm going to go and our next video, which is going to be coming up here in just a minute, I'm going to configure, since frame relay and routing is working and stuff like that, we're going to start locking some things down and getting some NAT working. And we'll configure some NAT and get it all situated. And I'll show you some static NAT. I'll show you some dynamic NAT. And then I'll show you some ACLs and how they work. So I hope this has been informative for you, and I'd like to thank you for viewing.